So we're going to talk about a technique that I've been using for a very long time called the sign chart. And it's really good for AP calculus problems like the following that I've mentioned. So like things like, oh, when is F increasing? When is it concave up? What are the points of inflection? Particle motions. It'll take part in all of these problems. And it's super important that you get this type of method down. And if you don't use this method, fair enough, use whatever you need. But I really think this is the best method, and it's the fastest in my opinion. So let's get started. So a great way, obviously, to introduce any topic is to think of a problem. So let's say I have a problem f of x equals 300 minus 3x squared. Or actually, we'll do 300 minus x cubed. Sorry. 300, let's actually change this. I'll do 300x minus x cubed. Let's say this is our problem. And I want you to find is when is f, lowercase f, when is f increasing? So the first thing that should be jumping to your mind is finding the derivative. And you're right, we need to find the derivative because we need to find out when this function is when this function's derivative is positive. So just take your derivative, and we're going to set this equal to 0. Okay. Factor out of 3, and we can just make this into this. And we're going to factor this even more. And so to find your critical numbers, we'll just get plus or minus 10, right? Now here's what we're going to do. Here's how the sign chart works. First, create a little f prime and x chart. Think of it like a number line. So, plot your critical numbers in order of least to greatest, like this. So negative 10 to 10. Top side is f prime and x is the bottom. Now, dotted lines are going to represent when the function is negative. Positive lines are when the function is positive. Okay? So, you're going to take a look at this right here. The part where you factored it out fully, and when you're the last step before you actually state what your critical numbers are. So this one right here. Now notice it's a product of two functions. So that's why we have two critical numbers. Okay. What are we going to do? So I'm going to label this one green and this one purple. So green is going to be this point, purple is going to be this one. Start with green. If you drew this function, it would look something like this. Let's say your x equals 10, and this is negative 10, right? So everything before negative 10, because negative 10 is an x-intercept. So every number before negative 10 is negative. Everything after is positive. So to the left of negative 10, we're going to draw a bunch of dotted lines. It's going to hit 0, so it's not positive or negative. And after negative 10 is hit, it's going to be positive forever and ever, right? That's how this function looks. And that's the idea of the sign chart. And we're going to do the same for the purple function. So if we have 10 minus x, this is going to be very similar, where at 10 there's going to be an x. 10 is going to be a pretty important, but it's going to start decreasing once it hits x equals 10, everything to the right of that is going to be negative. So 10 is our y-intercept as well, but the y-intercept isn't too important. Just graphically showing. So this entire everything to the left of 10, all x values to the left of 10 will have positive y values. So that's why we're going to do a filled in line up until 10 to represent it's positive to the left of 10, that x equals 10 for the purple function, and negative to every function after, right? This bottom right of the function is going to negative infinity at infinity. At x equals infinity, the end behavior is all the way down to negative infinity. Okay, so what are we going to do? So we just showed on a number line when a function is positive or negative, when its values are positive or negative. Now we're going to, because notice what we're doing. We're multiplying these two functions. So if we're multiplying them, we're going to do the same here. We're going to multiply the signs of each of these parts in between the critical points and away from the critical points. So this part on the left-hand side is a positive line, a filled-in line, times a negative line. What's positive times negative? That's negative. This line right here is positive times positive. Positive. This line right here is positive times negative. Negative. Okay, so now that we're here, let's go back to our question. When is f increasing? So when is f prime positive? Right here. So our answer, f prime is positive for the interval x on the interval from negative 10 to 10. And you could include these or not, it doesn't really matter. So f is increasing on this interval as well. So that's how we use the sign chart to do this. And that's it, guys. And you're gonna get faster at this, and faster and faster, and you're gonna get a lot better. It's going to take a little bit of time to understand what's going on here, but the best way I would explain it is you're really doing an analysis on the functions. You're taking a look at the function itself. Most cases on the AP, when you're asked problems on using the sign chart, you're gonna be left with a polynomial factor, a quadratic factor, or something like that. So it's nice. Linear functions are easy to do the sign chart with. Anytime you have e to the x, that's never equal to 0, so that's always positive, so you can ignore. For example, let's say I had the case where f prime of x was equal to like e to the x, right? E to the x times x minus 1. Well, if I do a sign chart on this and do the same thing, the only critical point is 1. And so the e to the x is it doesn't have a critical point. It has a horizontal asymptote. So it really doesn't matter. You know what I'm saying here? Right, this e to the x factor doesn't, it's kind of like it's always positive, so it doesn't really do anything. You could also have cases where you'll have fractional exponents in, you'll also have things like sine of, let's say you have sine of pi over 6t on the, on a certain interval from 0 to 12, and you want to, this is your f prime. Well, trig, if you want to do stuff with them, you're still going to have to find the critical points. So sine of pi over 6t is equal to 0 when t is equal to 0, 6, and 12, right, on this interval. It has infinite, technically. So you're going to plot all of these points on the number line. And, in this case, you either know it or you don't, in terms of the graph. So it's kind of hard to visualize what the graph's going to look like here. If you did know, like you would have to do 2 pi over b using b as pi over 6 and do all that stuff. In this case, for sine charts where it's not a polynomial, it's trig, you're going to have to plug in a single value between the critical numbers. In this case, only here. So for example, plug in 1 into this equation. Sine of pi over 6 times 1 is just sine of pi over 6, which is 1/2, and so it's positive. Right? Between 6 and 12, sine, let's plug in 7. Sine of 7 pi over 6, that's in the second quadrant. Or no, sorry, that's in the third quadrant, so it's negative. And then, yeah, so there you have it. So it's positive from 0 to 6, negative from 6 to 12. Okay? And in a sense, that makes sense. Like if you took a look at a sine graph, it's going to be, these are when your critical points happen. All the way up to here, it's positive. Obviously, this isn't the exact same thing, but you get the idea. There's critical points. So kind of that's another way to use the sine chart, is just to simply plug in points in between. And honestly, when you have things like x to the 5, 7 times like x squared plus x plus 1, x minus 1, something like this, or generally when you have fractional exponents, a good tip with the sine chart is to plug in values. So if you can do this, where you have linear terms, please use analysis. But if you can't, when you have cases like these, just plug in values in between the critical points that you found and the endpoints, of course, and just go with those. All right, that's it. That's all you're going to need to know about the sine chart. And I will see you guys. And actually, before I go, I want to point out, like, the reason over here, why didn't I, instead of solving it like this, I could have moved the 3x squared to the right. It's because I want to get this 10 minus x term. If I did 3x squared equals 300, and x squared is just 100, and x equals plus or minus 10, well, I have no idea from here if the plus 10 or minus 10 were negative linear functions or positive linear functions. In this case, I knew this was a negative, this was a positive, so it allows me to do better analysis. But yeah, that's all we're going to talk about for this video. This is how the sine chart works, and I hope you guys have a great rest of your day. Bye.